Hey y'all, Data Guy here. And today I got another viewer request video that y'all wanted me to make. Just what I think about the future of data engineering as a career. The landscape of data engineering, while it's still relatively nascent, it really only has kind of become a real defined separate career category from software engineering since around, I would say around 2005, 2006. The explosion of data from social media and the internet really taking full shape, the Web 2 age. And ever since then, it's evolved rapidly, pretty much nonstop, as there's been unprecedented data growth, technological advancements, and just the increasing importance of data-driven decision making in pretty much every business across every vertical, across every sector. And so I think the reason behind making this is it's really crucial to kind of understand the forces that will shape the field, identify potential areas of new interest, anticipate what might fall out of favor and no longer be a part of the data stack in 5, 10 years from now. And that's what I'm going to try and explore in this video. Think about what are the headwinds, what are the tailwinds, what might become more important in the future, what is probably going to no longer be as important to know in the future, just to give you as a viewer kind of a sense of, hey, where is the field of data engineering going? Is this something I want to devote my life and career to, or is this something that maybe I don't think is going to exist in 10, 20 years? And so I don't want to bother wasting my time trying to get into the data engineering space. That's what we're going to talk about in this video. So without further ado, let's get into it. So first thing I want to talk about are the headwinds facing data engineering. What are some potential struggles that data engineering might face in the future? And number one, and I think the one that's on top of everyone's mind was probably on the commenter's mind when they made this comment is, how is AI and ML going to affect data engineers? As are there going to be these AIs that come online that are suddenly able to do all the data engineering work? They're able to create data pipelines, manage all the data for a business, and then take my job. And so that's something, I think a lot of people in the tech industry are worried about is, hey, can an AI do my job better than me? And I actually think data engineers are uniquely well positioned to kind of avoid that threat of AI and ML taking people's job, because in order to have and successfully integrate AI and ML into your business, you're going to need to have good data. You're going to need to have well-engineered data. You're going to need to have someone that understands the underlying data that is powering those AI and ML models so that they can properly filter, adjust, test, build new models for those AIs and machine learning tools to actually use, and then set up the pipelines that are necessary to feed that data in, to programmatically train and retrain, to iterate, to make sure these AIs get better rather than worse. They don't degrade over time. To understand what inputs, what outputs affect each other. And so, while many people see AI coming into the data engineering space as almost a threat, I view it more as an opportunity. It's really just a new area that you're going to be in charge of. The term machine learning engineer is almost just like I think of it as another subsection of a data engineer, because that's really what it is. It is someone who is a data engineer who is specializing in the data pipelines that are designed specifically for AI and ML. So I really don't see, a tool coming out that's able to do that job anytime soon, because it requires so much abstract reasoning. It's not just something where you can say, hey, boop, 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 give me these inputs. You need to figure out what data is going to be most viable, what type of model is most effective, do testing and retesting and understand the needs of the business. So I don't view that really as a headwind, but that is something that a lot of people think, hey, maybe eventually down the line, someone's going to create an AI that can, take over the data engineering space, but I personally don't think it's happening anytime soon. A second headwind that I've seen is the complexity of data and technology. As there's just an ever increasing explosion in data sources and formats, the rapid evolution of technology, adding complexity to data engineering tasks, and integrating disparate data types and managing the proliferation of tools and platforms can really hinder efficiency and scalability and really make it difficult to do your job as a data engineer. And so that is something that is kind of a concern, for people that aren't in the industry. Maybe they don't want to work with a field that is constantly changing, where you're constantly going to need to learn new formats of data. You're going to, need to be able to manage all these different platforms, have all these different disparate skill sets. And so that is a potential headwind for some people that are not as committed to continuous learning. If you're going to want to be a data engineer in the future, you're going to need to commit to saying, hey, this field isn't going to look the same in 5 years. It didn't look the same 5 years ago. And it's really just going to keep iterating and keep having that burning desire to change and keep it built, working on yourself to make sure that you're staying ahead of the curve, making sure that you're staying up to date with all these new technologies. And the beautiful part about that too is even if you're not, there's always going to be someone younger and hungrier that will be. So that's really, even though some people might see that as a headwind, I personally view that as a challenge to really go after, especially for someone that is really just desire to get ahead of it and make their mark in the data engineering world. And then kind of compounding on top of that, you have a skill gap. The increasing sophistication of data systems really kind of necessitates to even get a base level understanding. You need to know data architecture, you need to know programming, you need to know how to use analytics. And the current shortage of data engineers, it's one of the most in-demand fields, one of the most in-demand professions. Kind of just indicates that it does really require a specific type of person with a really expansive set of tools to effectively do this job. Can't just be any Joe Schmo off the street. You really have to be dedicated to learning this industry, to staying on top of it, and just in general to really loving what you do in the data engineering space to become an effective data engineer, because you need to learn so much just to become a very basic level data engineer. Now, on the flip side of headwinds, there are also some nice tailwinds that are really propelling data engineering forward. And number one has the same thing as a headwind, which most people see as a headwind, I see as a tailwind, which are advancements in AI and machine learning. AI and ML are transforming data engineering by automating routine tasks, enhancing data quality, and enabling more sophisticated data analytics. And these technologies, even though they offer a lot of extra work, they also offer a lot of powerful tools for predictive modeling, anomaly detection, decision support systems, and also just making your life as a data engineer more powerful. Every action can have way more impact because you're able to multiply it by having, your AI assistant do some of the dirty work while you're doing more of the, higher level kind of thought processes. So compounding that is also, as you have this explosion of AI and ML tools, you need data to power those tools. You need someone that can actually understand what are the data flows, what are the inputs we need to get that desired output. What's going to actually help impact the business? What are some latent data sources that we're collecting and not actually using, identifying those, and then using those to power maybe a new AI model that's going to earn your business more money. And so advancements in AI and machine learning, I only see as a continuous tailwind into the space of data engineering going forward, as they'll kind of power more new use cases and also just make the average data engineer much more powerful within their business. You also have just the rapid proliferation of cloud computing. The shift towards cloud platforms has offered scalable, flexible, and cost-effective solutions for data storage, data processing, and data analytics, making it much more accessible for the average business and also allowing much greater scale for the larger enterprises. Services like AWS, Google Cloud, Azure are really the backbone of modern data infrastructure and facilitate much easier data management and collaboration, bringing many more people into kind of the sphere of data engineering and within the orbit of the data engineer. So you really are kind of the center of the new data universe. And also the rise of real-time data processing, as the demand for real-time data analytics is growing, having, machine learning models that update based on the most recent input down to the last second, you're just going to need more data engineers to actually manage that scale and that demand. Driven by applications in finance, in e-commerce, and Internet of Things. And technologies like Apache Kafka and Spark Streaming are enabling data engineers to process and analyze data in real time and provide businesses with really timely insights for decision making. So now that I've talked about the headwinds and tailwinds, I also want to talk about some developing trends and areas of future interest in data engineering. And number one, I would say, is data ops and automation. As organizations strive for efficiency and agility, data ops practices are becoming more prevalent. And what data ops means is really taking the best practices of software development lifecycle and software engineers and applying them to data engineering. Adopting things like CI/CD for your data pipelines, automating data pipelines, creating robust integration processes, adopting monitoring tools. All these things that have been prevalent in the software engineering space are now coming to the data engineering space and are really helping to enhance productivity and reliability for the average data engineer. And just giving them kind of a lot more structure, and also with that structure, a lot more kind of power in how they can shape and monitor data flows and use them effectively. The second trend I'm seeing is edge computing. The exponential growth of IoT devices and AI and ML tools, edge computing is kind of becoming more of a focal point where data engineering is going to adapt to decentralized models where data processing occurs closer to the data source, which reduces latency and bandwidth use. And instead of needing to call out to an external, just kind of centralized AI model, you can actually do the processing, on your own local computer, on your phone, or near where the device is actually taking place, instead of needing to have a monolithic architecture where you just have one big mega brain where all your AI and ML processes go through, but instead distributing that one large model out to many, many different micro models, each specialized to their particular use case. Um, and then finally, I really see the kind of lines blurring between data engineering and data science and ML engineering. I really just kind of seeing it be data engineering becomes a catch-all term for someone that has to do all of those things. A data engineer in the future might not just need to know how the data pipelines work and how to set them up, but also how to create data pipelines that power effective business applications, that power effective analytics engines, that power effective machine learning models. Unless that data engineer has a really deep understanding of the end result of where his data is going, it's just not going to be possible. So I see that really kind of becoming more and more of a necessity for the average data engineer, is being, more in touch with what the end result of that data is going to be. So, as we have all these areas of future interest, what is going to fall by the wayside? What is going to kind of fall out of favor in the data engineering space over the next few years? And number one, and it's kind of in their name, is legacy systems and technologies. We're really undergoing a generational shift, as you have, the older kind of generation that was used to on-prem databases, big monolithic architectures, big vendor lock-in. That is all kind of fallen by the wayside as cloud computing and modern data platforms are starting their era of dominance. Younger data engineers are in the seats, they're taking control of these budgets, they're getting to those management positions, and they're saying, hey, there's no reason for us to keep using these antiquated, just inefficient systems, right? And so organizations, I really see us moving away from traditional legacy databases of the past and graphic user interface based ETL tools, things where it's not everything is code, it's vendor lock-in and you have to do things these way, and low code but not really low code because you can't actually get the logic that code would afford you. I think those are all kind of going to go the way of the dodo, as organizations are going to move towards more agile, scalable, and cost-effective solutions that are completely cloud native. Um, and then another kind of thing that's going by the wayside, part and parcel with that, is manual data management practices. We're really seeing just the beginning of a move towards automation and AI-driven tools that are reducing the reliance on manual data management. Things like database administrators are, I think, going to become a thing of the past. And that's where I think some people have that misaligned thing of like, oh, we're losing the need to do all these manual processes, so data engineers aren't going to need it anymore. No, they're just going to be freed up to do more productive processes like developing new pipelines, creating new ways to use data. Really more exciting things to work on rather than just keeping the lights on and maintaining these really old, crappy databases. And so this just eliminates routine tasks like data cleaning, validation, integration, becomes more automated, becomes easier to do, and really just freeing data engineers up to focus on more strategic initiatives. And that's a role I really see taking place over the next few years. Now, on the flip side of that, some things that I think are going to become more important are number one, data governance and quality. With the ever increasing importance of data in decision making and driving these AI and ML models, if you don't have accurate data, you don't have actual good information to work off of, your AI and ML models are kind of just handicapped from the start. They'll never be able to be good if they're not built on good data. And the key to good data is good data governance. So ensuring data quality and governance becomes paramount. And so I see organizations are going to be investing more and more in data cataloging, data lineage, data quality control measures to ensure trustworthiness and compliance in all of their data sources. And then additionally, multidisciplinary skills. Like I said earlier in this video, is bringing in skills from software engineering, data science, from bringing in business acumen, understand how data is actually going to impact the overarching business. You're really going to need to see effective data engineers understand the broader data ecosystem and being able to communicate those insights effectively in a human language rather than just talking in data tongue that only other data engineers can understand. And so, in conclusion, the future of data engineering is really challenging and also really exciting. And as we kind of navigate the headwinds of complexity and privacy concerns, we also have tailwinds of technological advancements and the shift towards real-time data processing and cloud computing and AI and ML, offering promising avenues for future growth and innovation. We have areas like data ops, automation, edge computing. We have things like the power of developing the data for AI models. And we're also going to see a lot of stuff fall away. We're going to see traditional legacy systems kind of get replaced by cloud computing, by AI native, ML native systems. And so embracing multidisciplinary skills, focusing on data governance, understanding and just constantly evolving and learning with this ecosystem is going to be key for a data engineer to thrive in this evolving landscape. And so the journey ahead is very bright for data engineering, but it's going to be all about adapting to change, seizing new opportunities, and continuously learning to harness the full potential of data. So I hope you've enjoyed this video. I hope this hit the mark. And let me know how I did in the comments below. Data Guy out.